So very good morning to one and all. Today we are going to see the structure of electric power system. As I said on that day, we have discussed in the last class about the history of electric power system, how the electric power is being generated, even your DC power and as well as AC power. So when it was started, who it was started, so what are the size of customers initially, how it has been expanded, like that we have seen. So today we are going to see the structure of electric power system. Yeah. So last class we have seen up to this. So now we are going to see the basic structure of power system. Basic structure of power system. Nowadays, power system is a very complex and interconnected system, and vary in sizes and configuration. A large amount of electrical energy is generated in thermal, hydroelectric, and nuclear power and gas power station. So that is called conventional electric energy resources. Okay, conventional electric energy resources. Some amount of electricity is generated through non-conventional source of energy also. Non-conventional. That this power is also called green power. Green power, and it emits only less pollution when compared to thermal, nuclear, and gas. It emits very less pollution. So this generated electric power is transmitted to load centers. Load centers to power supply network consists of transmission lines, transformers, and your switchgears, transmission networks. And it is commonly classified into transmission system, sub-transmission system, primary distribution system, and secondary distribution system. Okay, so this generation also added here: generation, transmission, and distribution. In transmission system, it is further classified into sub-transmission system, then primary distribution system, and then secondary distribution system. Okay, the main purpose of transmission system, to connect all major generating station, say for example, your thermal generating station may be situated in some of the corner, and your hydro power station is situated in some of the corner, and your nuclear power station is situated in very large distance. If you take like the state like Telangana, so no nuclear power station is there. So we have to get the power from either from Karnataka or as well as the Tamil Nadu. So Tamil Nadu, there is some share. So even though the generation may be of 1,500 megawatt, like that. So separate okay, states have their own shares, 200 megawatt, 300 megawatt, and if you want more also, the government has to claim we want more power from nuclear. So we'll pay for the extra amount. So that will be some share. But even though if you want more power for managing the demand, so you need to pay for that extra extra importing that power. Okay. So what we are doing is we are paying. So the main purpose of transmission system to interconnect all major generating station and load centers in the system without supplying any consumers. Okay, there won't be any consumers in the transmission system. In the distribution system only we have the consumers. There won't be any en route in between. Next step. The generating voltages are generally between 11 kilovolt and 33 kilovolt due to the technical problems such as heating, insulation problem, and are stepped up with the help of generating transformers to connect the generators and the transmission lines. So generally 11 kilovolt generator may be there. So up to 25 kilovolt, it depends on the size of generators. Maximum they have reached up to 33 kilovolt. So even they may increase this generator size also. What it will happen is generally due to some heating losses or insulation problem. Okay, so this generator size may not exceeding this limit, that is 33 kilovolt. So if it is exceeding, so that might be generally losses, heat losses in the generator itself. That might be decreasing the efficiency of that particular generator alternator. So if the efficiency is dropping, simply dropping in alternator itself, so there might be huge efficiency loss in the your transmission and distribution system also. So generally, there might not be more generating, that is generation capacity will not be more than this. So generally, it will be within this one. So next, the generating and transmission system are often called the bulk supply system. Okay. Because generation and transmission system. What we are doing is after generating 11 kilovolt or 25 kilovolt, what we are doing is we are stepping up that 11 kilovolt or 25 kilovolt to 400 kilovolt or 765 kilovolt or 1000 kilovolt, and we are transmitting that power to very long distance. The interconnected transmission system of state or region is called grid of the state or region. I have already discussed the gridding system in the all over the India, and generally in the state also. In the state, if you take a state, there will be some state grid which connecting. If you take like the India, so there are 5 grids are there. Grids are there. First is southern grid, northern grid. Next is eastern grid, then northeastern grid, western grid. So all these 5 grids are connected together, and each state having the state headquarters, that is state grid. State grid is there, in which that state grid comprising of combining all your load dispatch centers, and as well as some mini grids. Okay, maybe framed in your state itself, and depends on the districts. Some combined lead to 4 or 5 districts combined together, they will be forming a load dispatch centers. That load dispatch center is connected to the main state grid. That state grid is connected to the we are connected to Southern Regional Load Dispatch Center. So that is located in Bengaluru. Southern Regional Dispatch Center, if you take, it comprises of 5 states and 1 union territory. Okay, it comprises Tamil Nadu, Kerala, Karnataka, Andhra Pradesh, then Telangana, and Puducherry, 1 union territory. So this all combined together, and it is being connected with Southern Regional Load Dispatch Center, which is located in Bangalore. So here, if you take, state grids are interconnected with the help of tie lines and form the regional grid. Next, in India, power system in most of the states are owned and operated by State Electricity Board, that is SEB'S. So now the SEB'S are dissolved. So we are this is the old system, SEB'S and all, state electricity boards and all. So even though state electricity boards is there, so that is being restructured to generation corporation, state generation corporation, transmission corporation, distribution corporation. So which generate, transmit, and distribute power within the state territory. So before the 2010 and some other states it extended up to 2012 2012 like that. So before that only state SEB'S, that is State Electricity Board. So only one utility might be there. Okay, so that we call it as a vertically integrated system. If you take like your Telangana State Board, Electricity Board, previously it was like Andhra Pradesh State Electricity Board. So Andhra Pradesh State Electricity Board is a single entity. It is a single entity which covers all these three, that is generation, transmission, and distribution, and also collection of tariff also. Even the integrated state. Previously, it was an integrated state, combined like Andhra Pradesh and Telangana. So if you see like Andhra Pradesh and Telangana, so one electricity board, Andhra Pradesh. Even if you see some of the boards in some other in Telangana, it will be reflecting Andhra Pradesh electricity board. But that was dissolved. That was dissolved, and now it is after Telangana state formation. So they divided Telangana State Electricity Board. Further, it is being divided into Telangana State Generation Corporation, Telangana State Transmission Corporation, Telangana State Distribution Corporation also. So in Telangana State Generation Corporation also, it is further divided into northern region, southern region, and the transmission also northern region, southern region like that. Telangana State Southern Regional Corporation, Telangana State Northern Regional Corporation, like that it was divided. So in this system, this is the new restructured system. In addition to state electricity board, which was controlled by respective state government. Okay, so state government only overruling all this generation corporation, transmission, and distribution corporation. So utilities operate in metropolitan cities like Mumbai, Kolkata, Ahmedabad, etc. Also. This is not old. I said no. So 5 regional electricity board, like Northern Regional Electricity Board, Southern Regional Electricity Board, Western Regional Electricity Board, Eastern Regional Electricity Board, and Eastern Electricity Board. So this is reframed as Northern Regional Grid Corporation. That is Regional Dispatch Center, Northern Regional Dispatch Center, Southern Regional Dispatch Center. This later it was formed like that. Okay, so which to promote the integrated operation of regional power system, the responsibilities of regional electricity board to review project progress, plan integrated operation among the utilities in the region and in that region, then coordinate the maintenance schedules, determine the availability of the power for interstate utilities transfers, like that. So still this interstate utility transfers also that say particular region, say Telangana region is having power deficit of 500 megawatt or 1000 megawatt. So what we are doing is whichever the region which is having more excess power generation, what we are doing is simply we are simply we are importing that power from nearby regions, and what we are doing is we are just paying that amount for that particular states. So like that also power exchange, the utility power exchange also that. The name of the state, this is the previous state. So if you see like Northern Regional Electricity Board, it combines the state of Chandigarh, Delhi, Union Territory of Delhi, Haryana, Himachal Pradesh, Jammu and Kashmir, Punjab, Rajasthan, UP, Uttar Pradesh, Uttarakhand. Next, Western Regional Electricity Board, Chhattisgarh, Dadar and Nagar Haveli. Next, Daman Diu, Goa, Gujarat, Madhya Pradesh, Maharashtra, like that. So Southern Regional Electricity Board. It combines the previous Andhra Pradesh, integrated Andhra Pradesh, Karnataka, Kerala, Lakshadweep, Pondicherry, Tamil Nadu. Okay, so Lakshadweep also added. Lakshadweep also added in like previous Southern Regional Electricity Board. Next, if you take like Eastern Regional Electricity Board, Andaman Nicobar Islands. Next is Bihar, Jharkhand, Orissa, Sikkim, West Bengal. Next, Northeastern Regional Electricity Board combines of Arunachal Pradesh, Assam, Manipur, Meghalaya, Mizoram, Nagaland, then Tripura. Okay, so this is the integrated installed capacity as on 2008. This I am coming later because this is the old data. This I am coming this old data later. So these are all the electricity corporation also integrated with the previous that SEB'S in addition to the electric organization described above, there are some central government organization also. National Thermal Power Corporation, that is NTPC, then National Hydro Power Corporation, NHPC, Nuclear Power Corporation, that is NPC, then Damodar Valley Corporation, DVC, then Bakranangal Base Management Corporation, BBMB. So which operates large thermal, hydro and nuclear power station and supply bulk power to the electric utilities for transmission and distribution. Next, Power Generation Corporation. Power Generation Corporation is responsible for bulk power transmission to extra high voltage. Extra high voltages lines beside your SEB'S, Northern Regional, REBs, next Western Regional, and 60% of charge total being installed capacity of India. Okay, so these are all large power producers, large capacity of power producers like NTPCs. You already know this one. Next is sub-transmission system. Sub-transmission system are used to transmit power for large consumers. It is very difficult to distinguish your sub-transmission system from main transmission system. In India, which we supply power to large consumers. So large, there are some large consumers also there. So which they may get 132 kilovolt and 66 kilovolt, etc. Moreover, 132 kilovolt system comes under transmission system. In earlier days, when transmission voltage was not high, so by that time they are getting 132 kilovolt. So later they may be able to get only 66 kilovolt, 33 kilovolt, 11 kilovolt directly to the companies, like where they need a huge power consumption. So in earlier days, when transmission voltage was not high, lower voltages are used for lower voltage transmission system are termed as sub-transmission system. So sub-transmission system. So energy is often converted into electrical form, which is used in the form of heat, light, and mechanical energy. Next, utilization of power is restricted to low voltage only. So before feeding the power to consumers, the transmission voltages are stepped down and the power is transmitted. Secondary distribution system also. It's a secondary transmission forms the link between the main receiving station and main secondary substation. At secondary substation, the voltage is being stepped down and the power is being fed into primary distribution system, which feeds the power to medium large consumers at distribution voltage over the 400 voltage or 765 voltage, etc. So it is normally 33 kilovolt, 25 kilovolt, 11 kilovolt, and 6.6 kilovolt in India. The secondary distribution feeders supplies residential and commercial consumers at 400 volts. As I said, like a pole-mounted transformer. So generally, it transmits over 400 volts to 440 volts. Next, the distribution system have largest share in the power network. So if you see this is the structure of this is the structure of the whole modern power system. So if you see here, so generally the power is being generated. Power is being generated like a generator size maybe of 11 kilovolt to maximum 25 kilovolt. Okay. So what we are doing is, so we are generating the power, that is generation station or generating system. So that is being step up to 400 kilovolt or 765 kilovolt or 1000 kilovolt. Okay, like that we are transmitting. So that is the what we are doing is we are stepping up. So stepping up the voltage. Okay, so here if you see interconnected transmission and transformation system. So that what we are doing is we are stepping up the voltage to 400 kilovolt, 220 kilovolt, or 132 kilovolt, or 765 kilovolt, or 1000 kilovolt. Okay, so that we can call it as transmission system. So here not only one generating system, there is a many generators. See, not only this 3 generating system. So there are n generating system. If you take the okay, in the particular state or in the particular district, there may be of 20 generators, 30 generators. It's being connected to particular okay district, or if you take the whole state, there might be of more than 100 generators being connected okay, to satisfy the particular demand to that particular states. Okay, so if you see like interconnected transmission system, so that 11 kilovolt or 25 kilovolt is being stepped up, and like if you see like in generating station itself, there might be of switching substation, substation, or step up okay substation. There only this is possible. Okay, so if you visit some other like generating system, there might be a separate substation. So there you will be finding this step up substation, substation, or switching okay like substation, in which the power is being stepped up. So that is being connected by a tie line. Okay, tie line is like many transmission lines is being connected to that particular transmission line. So that is through the tie lines. So next is sub transmission system. So sub transmission system. So here if you see like generally 400 kilovolt is being transmitted over very large distance, or 765 kilovolt. So that 400 kilovolt or 765 kilovolt is being stepped down. So generally if it travels over 100 kilometers or 200 kilometers, there you will be finding switching substation. So in the switching substation, what they will do is they will generally step down that 400 kilovolt to 220 kilovolt. Okay, so further that 220 kilovolt is being transmitted over very large distance. That is for another 100 kilovolt. So there again after 100 kilovolt, you will be finding another switching substation. That 220 kilovolt is stepped down into 110 kilovolt. So you will be finding in the deep forest or in the deep remote places, you will be finding this switching substations. That is, if you go inside the, if you want to locate that switching substation, you have to go a little bit inside your villages or in the remote places. You will be finding this switching substation. That is 400 kilovolt bar, 220 kilovolt switching substations. Like that you can find in your nearby place also. If you find free time, you can go to nearby substation and you can find out what is the rating of that particular substation. So generally you will be finding 33 bar 11 kilovolt substation nearby your place. Next thing is that 220 bar 110 kV substation. 220 bar 110 kV substation also one of the switching substation. And again, you will be finding 110 bar 66 kilovolts substation. So that is the sub-transmission system. So sub-transmission system is 66 kilovolt. So 66 kilovolt, sometimes you will be finding large consumers, some companies, they want they might be having acres and acres of land. They will be operating with huge employees, 1,000 employees, 2,000 employees in a one single stretch. So that kind of companies need very more huge power. So what they will do is they will generally bought 66 kV supply itself for their purpose. Or you will be finding you will be finding another if you see like a primary distribution system. Primary distribution system, you will be finding this 66 kilovolt is further being stepped down to 66 to 33 kilovolt. 33 kilovolt or your 11 kilovolt. That's what I said now. So you'll be finding your substation of size of 33 bar 11 kilovolt. Okay. So and if you see in that sub transmission system also. So nowadays that is connected to small generating unit system. So mini hydel power plant, like a mini thermal power plant. So mini thermal power plant, what is the generation size might be of 10 megawatt, 5 megawatt, 15 megawatt, 20 megawatt. Because as I said, hydropower is being generated. In that particular first stage of hydropower power station, you are able to generate around 500 megawatt. Next, second stage also similarly, like 500 megawatt or 200 megawatt to 300 megawatt is being generated. So again, that water is flowing through some long distance, and that is being flow to your rivers and all. So what we are doing is we are not letting simply that water to your rivers or some canals like that. So again, what we are doing is we are utilizing that energy. So that's why we are some small hydro power station are being installed. Okay, so that from that power station also we can generate and we can give to the grid. So that is of this is being generated. That is of like a 20 megawatt, 15 megawatt, 10 megawatt is being generated. So that is being given to your sub transmission system. That is directly given to 66 kilovolt system. And in remote places, you will be finding mini thermal power plants also. So that is of 5 megawatt, 2 megawatt, 1 megawatt, like that and all they are doing. In some other villages, you will be finding more firewoods. So what they are doing is, so from that firewoods itself, that power is being generated in there itself. So small generators, they are being installed 1 megawatt, 5 megawatt, 2 megawatt. So they are utilizing, because simply like that firewood, what we are doing is we are just wasting that firewood. Okay, so what they are doing is that a particular village panchayat itself, they are collecting all the firewoods and they are collecting to a particular place, and that power is being generated. And if you see like the primary distribution system, you will be finding 33 kilovolt, 33 kilovolt or 11 kilovolt. So there are some consumers, they want 11 kilovolt itself. Like instead of 415 kilovolts, they simply want like 11 kilovolt itself. That is medium okay, consumers, medium large consumers. So some companies they will be operating with 100 employees, 200 employees. Their power requirement might be of very huge. So they are going for this 11 kilovolt directly. And if you see like any your companies, so in front of the gate itself, you will be finding some okay, one transformer will be there in front of the gate. Near to the gate itself, you will be finding one like pole mounted transformer will be there. So sometimes they will be taking directly 33 kilovolt. So that if you see, if you go near to the transformer and if you see the nameplate detail of that particular transformer, you will be having 33 kilovolt bar 11 kilovolt. Okay, so 33 kilovolt supply they are taking, and that transformer rating of 33 bar 11 kilovolt. So they are utilizing only 11 kilovolt. Sometimes they are directly 33 kilovolt. Like that depends on the consumers. Okay, so if you see like secondary distribution system, so secondary distribution system where we connected, that is domestic users like a 3-phase supply or single phase AC supply, like that. So by the time like 11 kilovolt or 33 kilovolt is passed near to your home. So if you see like near to your areas, you will be finding 11 kilovolt okay, pole mounted transmission system. So from that okay, like transmission wires, so only 3 wires will go. So after that, your distribution transformers, DTs, that is distribution transformers, that is pole mounted transformers. So after that, that 3 wires is converted into 4 wires. Okay, so that is delta to star connected transformers. That is of delta to star connected transformers. So like already you studied in electrical circuits. So what is delta connection? How the delta connection is being converted into star connected system. So that if you see the nearby pole mounted transformers, okay, so today also you can see, go and visit nearby your pole mounted transformers. What is the rating? So that rating is of 11 kilovolt bar 415 volts or 440 volts or 400 volts. Okay, it depends on the system what we are implementing. So you will be finding. So there you will be finding after pole mounted transformers, you will be finding 4 wires. 4 wires. That 4 wires is being transmitted to your nearby streets also. So what we are doing, if you are applying for 3-phase connections, what they will do is they will in your house connections, you can see like that may be 4 wires. So one is neutral wire, then 3 supply. Then 3 supply wires, that is RYB. Okay, that neutral wire is itself acting as a stay wire for that particular house. And also, if we want a single phase AC supply, you will be finding sometimes 2 wires, sometimes 3 wires. So sometimes they will be finding one stay wire and one neutral wire and one supply wire, that is phase wire, like that. So simply we are enjoying the power in the consumer side. So this is the entire structure of power system. Okay, so this is the one of the 2-mark question. 2-mark question like that you might be asked. So don't study for only the 2-mark question. So generally, now without seeing your book also, you can draw this. Okay. The entire structure of power system very easy. Okay, so I'm repeating once again. So this is the entire structure of the power system. So here, if you find the generating system of 11 kilovolt to 25 kilovolt, so that is being stepped up. stepped up into like 400 kilovolt or 765 kilovolt, like that. So that is the transmission system, general transmission system. So you will be finding not only one generating station, that is the series of many generating station. So that is being collected through tie lines. Tie lines means another transmission system. So again it is being transmitted over very large distance. And again that 400, you can also add one more block also here. One more block also here, that is 400 kilovolt is being stepped down into 220 kilovolt. That 220 kilovolt, okay, so being transmitted to some more distance. Again, that 220 kilovolt is being stepped down into 110 kilovolt. So again, so that is called after 110 kilovolt, again it is being stepped down into sub transmission system, that is of 66 kilovolt. So that transmission system we call it as 66 kilovolt. Okay, so that 66 kilovolt sometimes is being supplied to large consumers, and that is customers or consumers. And also, so in that sub transmission system, you will be finding small generating stations also, like mini hydel power station or mini thermal power station, like that also, or mini gas generating power station, or mini solar PV power station, or wind power thermal wind power station. That is of if you take like solar power system, that is of 1 megawatt to maximum 5 megawatt, 10 megawatt. It depends on the size. So that is being connected with the sub transmission system. So again, further it is traveling for some kilometers to 20-30 kilometers. Okay, so again it is being stepped down into 33 kilovolt. So that 33 kilovolt is again being transmitted over some 5 to 10 kilometers. So again, what we are doing is that 33 kilovolt is stepped down, and again 11 kilovolt is being transmitted over some long distance, not a long distance, some like 5 kilometers or 10 kilometers, with that range. So that is being given to that 11 kilovolt is directly taken by your large consumers, or otherwise that is 11 kilovolt is further stepped down into 11 kilovolt bar, 415 kilovolt or 440 kilovolt. Again, that is being taken by ourselves. That is our small consumers. That is 3-phase AC supply or single-phase AC supply. So this is the entire structure of the entire power system. Okay. So with this, we are going to wind up